Hey, it's Mr. K. Let's talk about calorimetry, specifically Q equals mc delta T. So the Q is talking about the energy being transferred. M is the mass of the sample that's either heating up or cooling down. C represents the specific heat capacity. And delta T represents the change in temperature. You can find the listed specific heat capacities on page 3 of your data booklet. We've got air, polystyrene, copper, aluminum, iron, tin, and water. Okay, let's get started with a couple examples. Example number 1, how much energy is required to raise a 100-gram sample from 25 degrees Celsius to 55 degrees Celsius? Let's start with aluminum. So we write our formula, equals mc delta T. Now we're just looking for how much energy. We were given a mass and we're given a change in temperature. Okay, so our mass is 100 grams. The specific heat capacity is 0.897 joules per gram per degree Celsius. Again, I can reference that right here in my data booklet. And then my delta T is my change in temperature. Again, that is final minus initial. So I'm going to put a parentheses here. 55 is my final minus my initial. And I get my answer here. And it should be 100 times 0.897 times parentheses 55 minus 25, close parentheses. Should look just like this. 2691. Okay, so that's 2,691. If we look at the units, grams cancel grams, and these Celsius are going to cancel the Celsius in this bracket, as it's going to be one big Celsius. So I'm left with joules. Often it will ask me to report these in kilojoules. I should be confident with those unit conversions. Alright, now let's talk about different heat capacities. I've got 0.897 for aluminum and 0.227 for tin. A specific heat capacity is the energy necessary to raise 1 gram by 1 degree Celsius. So we need 0.897 joules for every 1 gram for 1 degree Celsius. For tin, we need less energy. Less energy is going to cause a higher increase in temperature. So this time, we're doing the same temperature, and we're going to figure out how much energy we need. Oftentimes we get asked these comparison questions. Which one will do more or less? Let's take a look. It's still 100 grams. My heat capacity is 227. My temperature change is still 30 degrees Celsius. 55 minus 25. My grams cancel grams, Celsius cancel Celsius. And it will be 100 times 0.227 times 30. Okay, this time I get 681. $681 joules. So I could be asking you comparison questions here, like which one should require more energy for this process. For that, you could do the math, even if they don't give you a mass, and they just say to raise a sample by a set temperature for a set mass, which of the two would require more or less energy? Well, higher heat capacity, it needs more energy to change temperature. Lower heat capacity, less energy. Water is 4.19, so it would need a lot of energy to raise 30 degrees Celsius. Alright, similar question, just looking at it from a different perspective. So this time they're saying 10 kilojoules of energy is transferred into a 250 gram sample, initially at 25 degrees Celsius. Find the final temperature. Okay, there are two ways we can do this. In terms of the algebra, I'll show you both. So we start off with Q equals mc delta T. And the first thing I want to do here is find my red pen to show you a bit of algebra. So I'm looking for the final temperature. Really, I'm looking for delta T. Oh, and because I'm looking for delta T, I'm going to divide mc on both sides. And then I'm left with delta T equals Q divided by mc. I know my Q is 10 kilojoules, but because my heat capacity is in joules, I'm going to change my Q to joules. I have my mass, which is 250 grams. And I have my heat capacity for aluminum. Grams cancel grams, joules cancel joules. I'll be left with degrees Celsius. Remember to use using your brackets here. You can see that I've used 10,000 divided by 250 times 0.897. And that gives me 44.6 degrees Celsius. Now, careful here, because that's the change in temperature. That's not my final. Okay, now the energy is being transferred into this sample, meaning that because it's gaining energy, it's going to increase in temperature. So now, if I look at my delta T, TF minus TI, we do a couple things here. To get rid of this TI and to get TF by itself, I'm going to do the opposite. So TF was subtracting TI. If I add TI to both sides, I isolate TF. So now I see that final temperature is equal to the initial temperature plus the new change. The initial was 25 degrees Celsius. The change was 44.6 degrees Celsius. I add those, and I get 69.6 degrees Celsius as my final temperature. Okay. All right, let's look at another example. So again, this question could be asked something like, if I transfer 10 kilojoules of energy into 250 gram samples, or the same massive sample of aluminum tin, which one's going to reach a higher final temperature? So without even using the math, think about it for a second. This is so much energy to raise 1 gram by 1 degree Celsius. This is the energy to raise 1 gram by 1 degree Celsius. So if I put 10,000 into each, which one's going to go up higher? Let's do the math. All right, this time I'm going to stretch out the algebra a little bit. All right, so this time, instead of just solving for delta T, I put in TF minus TI. Algebraically, first thing I'm going to do is I'm going to divide both sides by MC. That gives me Q equals MC. Or sorry, Q divided by MC equals TF minus TI. Next up, I want to solve for TF, so I'm going to add TI to both sides. Cancel, cancel. And now I'm left with a formula that looks like this, very similar to the first one, just not in pieces. Okay. So, I take my Q, which was 10 kilojoules, I change that into 10,000 joules. Divide by the mass of 250 grams. My heat capacity is still up here, 0.227 joules per gram degrees Celsius, plus my initial, which was 25 degrees Celsius. Okay, 10,000 divided by bracket 250 times 0.227. Alright, so when I put that in my calculator, 10,000 divided by 250 times 0.227, I get 176. So that's basically my delta T, but now I'm going to add it to 25, which is my initial, and I get 201. Okay, there's the ins and outs of heat capacity. We'll come back and talk about labs. Thanks for tuning in.